Okay, I want to start topic 7 just by saying that this is a weird lesson. It might blow your mind a little bit because this is one of those things that I need to expose you to, but I am not exactly sure how deep into it I need to go, and I don't think I need to go very deep into it, but it's kind of weird if you don't. So, um, all that to say that if this blows your mind today, if you walk away being like, I have no clue what she just said, don't even worry about it. There's going to be 3 questions on our test over this, and they're going to be the most basic form of a question over this topic that I can possibly muster. So don't worry about it if this freaks you out, okay? So looking at this table on the left-hand side, I have 8 to the half squared, okay? Now we haven't really dealt with fractional exponents yet, but you just treat them just like normal. So 8 to the half squared would be right here, 8 to the half times 8 to the half, right? Well, we know, based off our exponent rules right here, that I add those two things together and I get 8, right? Well, looking at the first column and the last column, 8 to the half squared is the same as 8, okay? So let's see how this translates across. The next one, 3 and a half, or 3 to the half squared. That would be 3 to the half times 3 to the half, okay? Again, my exponent rule says that I need to add those together, which would be just 3 as a whole, right? I could even do this last one a little bit differently. I don't have to. 5 to the 1/3 to the third would be 5 to the 1/3, 5 to the 1/3, 5 to the 1/3. Even if I wanted to apply a different rule, let's actually apply the power rule, right? If I have 5 to the 1/3 to the third, I also know I can just multiply these two things together, right? So 3 times 1/3, that's still just 5 to the 1, or 5, okay? So looking again at my first column over here, and my last column over here, what can we deduce about when you take a exponent that's a fraction and raising it to the opposite power, right? You just get the base. So let's expand that a little bit more. When can you square a number and get the same number? Okay, and you can kind of already see the answer as I'm turning to this page. But let's think about all this work that we've done with radicals, right? When we did square root of 3 times square root of 3, we would get 3, right? Well, isn't this squaring it? Square root of 3 squared, isn't that the same number, 3? So squaring a number, in other words, squaring a base, and getting the same number happens with radicals. So that was kind of a very loose interpretation of this rule right here. A to the 1/2 is the same as the square root of A. Okay, again, kind of a weird jump there to go from an exponent to a radical, but they are the same. A to the 1/2 is the square root of A. Furthermore, you have a to the 1 over n, which is the nth root of a. Okay, that's this box right here. Now we'll talk about that more in just 1 second, so put a pin in that. Let's just look at number 1 in this box. 100 to the 1/2, that can be rewritten as the square root of 100. And even more so, well, what is the square root of 100? It's 10. Okay, I would say this box right here is about the knowledge that you really need for my class. Now, I'm about to keep going and blow your mind some more. But if you can understand that raising a number to the 1/2 is the same as taking the square root and actually work it out, then I'm going to feel good about what you've learned, okay? But let's look at number 2. It says 16 to the 1/4. Okay, that's totally different. Based off of this box over here, the second box, that means that it's kind of like taking the square root, but you're actually taking something called the 4th root. You put a little 4 right there. That number is called the index, okay? Typically, we use square roots, and so our index there is a 2, okay? Over here, I could write a 2 on my square root symbol here. We just don't because typically that's all you use is a square, or a square root. What the 4th root is saying on number 2 here is that we're trying to think what number times itself 4 times equals 16. So what times what times what times what equals 16? Typically, like on number 1, we were just looking for what times what. That's what a square root is 2 numbers. On number 2 here, the 4th root is looking for a number times itself 4 times. In this case, it would be 2, right? 2 times 2 times 2. So really, the answer to this one is 2. I don't even think you have to go that far. If you just can know that 1/4 is the same as a 4th root, I'm cool with that. Don't even worry about getting it to the 2 part, okay? So number 3, 100,000 to the 5th power, that's going to be 100,000 to the 5th root. Okay, I'm not even going to work it out. I think the answer is 10, but I'm not going to work it out. Number 4, 27 to the 1/3, that's 27 to the 3rd root. Again, they're wanting to know what times what equals 27, which is 3, but I'm not even concerned about that. I just want to see if you can rewrite these. Number 5, 81 to the 1/2. Well, that's just the normal square root of 81. You could put a 2 here if you wanted to, but typically we just know that without it, it is a square root. So don't worry about it if that's what you're used to. So in this one, we actually could work it out, right? We're pretty good at square roots. Square root of 81 is 9. Okay, number 6. This would be the third root of 216. First answer 6 if you're curious, but I don't care. Number 7 would be just the square root of 144, which again, we're pretty good though, so I'm going to go ahead and answer it. That would be 12. Number 8, this would be the fourth root of 1, which this one is kind of interesting. It's saying what times what times what times what is 1. Well, obviously the only number to put in there is 1, right? Number 9, square root of 225, which we know is 15. Number 10, I'm going to let y'all try it. I'm going to give you a second. Hopefully you wrote the square root of 49, which means my answer is 7. 11 would be the cube root, or the third root. Usually they say cube root of 1,000, which would be 10. The last one, again, hopefully you could do this one, just square root of 25. So our answer here is 5. Okay? Now again, just to recap, all the ones that I didn't create an answer on, I just did that to show you that I'm not worried about it. If you do not know how to calculate a cube root right now or a fifth root, I'm not concerned at all. Okay? If you want the answers, the answer here is 6, the answer here is 10, the answer here is 3, 1, and 10. But again, I'm more concerned that you understand just the square roots. So if you can turn it into the radical symbol, great. If you can answer it, cool. But I'm really just concerned, can you turn it to the radical on any of them, and can you answer the square roots? Okay, so now we have some more practice here, and this is where it gets a little scary. So if you understood that last box, you're good to go. I cannot stress that enough. If you understood the last box, you're good to go. This is when you kind of have to start putting all of our rules together, and I'm just going to kind of work through these one by one. This is where the video is going to get a little long. Hopefully you understand. Again, if not, don't even worry about it. Don't even stress. Don't even come to tutoring. It's not a big deal. Don't stress. So number 1, 25 to the 1/2. Actually, let's read the instructions. It says write each expression in radical form. Okay, so like number 1 is an exponential form, so we want to write it as a radical. Or write each radical in exponentials. Like number 3, we want to change to an exponent. Then it's going to say you may want to simplify the radicals before you begin, and then you must simplify the radicals that are in your answers. Okay, so for example, number 1, it's an exponential, so I'm going to change it to radical form, which would be the square root of 25, because that's what a half means. However, I can simplify this radical because the answer is just 5. Okay, so let's look at number 3, 18. Square root of 18. Well, that's starting as a radical, so they're wanting me to change it to an exponential, right? But I need to make sure that I can't simplify this first. And I can. This is the same as the square root of 9 times 2. So really, I take my 9 out, and I get 3 root 2. Well, I still have to change this to an exponent. At this point, the radical is only on the 2. So this would be 3 times 2 to the 1/2. Notice I didn't put the 1/2 on the 3 because it's not in the radical sign anymore. Okay? Ooh, these numbers are very strange. 1, 3, 5, 7, 2, 4, 6, 8, 9, 10, 11, 12. I just realized that. Oh well. I'm going to keep just going across the top. 15 to the 1/2. Okay, well that's going to be the square root of 15. I can't simplify that because 15 doesn't have any factors that are perfect squares, so I'm done there. 7. Let's go ahead and simplify this first. So that would be 4, because the square root of 16 is 4, and then root p. Okay, well when I change that to exponential, 4 doesn't have an exponent anymore, but the p is to the 1/2. Okay. Number 2 over here, going way out of order, says 5x to the 1/2. Well, notice that that 1/2 is only on the x. So 5 is not going to be inside of the square root symbol. Okay. Going across, square root of 3s. I can't simplify that, so I can just change it to the exponential. I've got 3s, but all of it is going to be raised to the 1/2, right? Because it's all underneath that radical symbol. Now, if I wanted to, I could actually rewrite this as 3 to the 1/2, s to the 1/2, if you wanted to. You don't have to by any means. That's just distributing that 1/2, but you can. Okay, number 6, we've got -4, and then 2x is being raised to the 1/2. So -4 is on its own, And then I have in my square root 2x. Okay, both of those are being square rooted because they both have the half. Now I can't simplify that, so that one's done. Number 8, this is kind of the opposite of the one we just did. We've got -2 on its own, and then we have all of 8t and u being raised to 1/2 because that's the square root symbol. Okay, this bottom row starts incorporating the different types of radicals that we have. So number 9, for example, is a cube root. So that means 3s squared is all being raised to the 1/3 this time. Okay, and remember, like I said before, on number 4, we could distribute this 1/3. So really, if I wanted to, I could rewrite it as 3 to the 1/3 and s to the 2/3. I got 2/3 because I multiplied 1/3 times 2. Okay. All right, number 10. Let's try to simplify this first. Okay. The 4th root, actually, no, I'm not even going to do it. We're not going to worry about it. I don't care. So I've got 16x squared. Switch colors on me there. Actually, I don't want to switch colors. Go back to blue. So I've got 16x squared, and it is all being raised to the 4th power because it's got a 4th root here, index of 4. So now, if I wanted to, I could distribute that 1/4, and I'd have 16 to the 1/4 and x to the 2/4, which really would be a half, right? So 16 to the 1/4, x to the 1/2, because I would simplify 2 over 4. Okay. Number 11, all of this would be 3xy to the 4th inside of 1/6, right? Because the 6th root would be 1/6. And again, if I wanted to, I could distribute. So I've got 3 to the 1/6, x to the 1/6, y to the 4/6. Because remember, this is like 4 over 1. So 4 times 1, top times top, 1 times 6. Now again, I could simplify, and I would get 3 to the 1/6, x to the 1/6, y to the 2/3. Okay. Last one, all of this is inside of the 1/3, so I've got 27 y to the 4th underneath a cube root. Okay. Now again, if that was blowing your mind, do not stress. I care way more about the table that we did before this. Okay. However, next part, if you flip to the back of your page, it says look at number 9 above, and really that's on the page before. What happened to s? So I'm going back to number 9 here. On number 9, s had an exponent of 2 inside, right? But then we put the 3rd root on it right here, and it became 2/3, right? Well, how would I separate that to go back to the radical? I'd have to notice that the bottom was the root over here, and the 2 on the top was the exponent on the s. Okay, so if I were to summarize that, I would use what this box says over here. Okay, the top number, I'm going to erase that arrow, it's confusing. The top number is your exponent, just like normal, and the bottom number is called the index. And this is slash the root. Okay, and you can kind of see where that appears. That's the number that appears above the radical symbol on the outside. Okay, and then the x ended up showing up right here. Okay, so let's try this out. One, it says 100 to the 3/2. That means the bottom number, so in this case the 2, is my index. And I'm going to write it even though square roots we don't really need to, just so you can see the consistency. And then I've got 100 to the 3rd. And I'm not going to work any of these out on this page. Okay, number 2 would be 16, obviously. But then the bottom number, the 4, is my index right there. And the 3 is my exponent. Okay. Number 3, same thing. Got my little root symbol. Got 1,000. The top number 2 is my exponent. Bottom number 3 is my index or my root. Okay. Now you can work these out. I'm just choosing not to because I don't think we need to go that far. Number 4, draw your radical symbol. You got 25. Bottom number is the index 2. Top number is the exponent 3, etc. Now, let me just pause on that one just so that I can show you how to work it out. If you think about this one right here, 25 to the 3rd. I don't know what that is. I could go get my calculator and see. But I could work out 25 to the 3rd. Let's see. Let's see if I can just work it out. 125 squared, 625. Okay, so we would get, I'd pause the video there, I can do math. we would get the square root of 15,625, okay, because that is 25 cubed. Then the square root, that's what the 2 means, you just take the square root and see what times what gives you that, and we would get, oops, typing it in, 125. Okay, so you can work these out. I'm just not concerned about that right now. That's not the focus of this lesson, so I'm not going to work any more out. I just wanted to show you that you could. Okay, number 5, excuse me. I'm just going to continue on. This would be a good time to maybe pause the video, finish them all out, and then check to see if you got them all the same. In fact, I'm going to pause and just write them all in, and then you pause, and then hopefully we've got all the same answers. Alrighty, so here's the answers I got. I'll give you a second to check, or you can pause. Notice on number 8 and 12, I actually went ahead and worked them out. 8 was just to the half, so I knew that was just a square root, so I went and took the square root of 81 and got 9. 12 was just to the negative 1/2, which meant that I had to flip it to the bottom, but then it was just 1 over square root of 121, so 1 over 11. Okay, we're almost done. The blue cover of your notes packet has this as the very last row of the laws summaries. And this is what we just discovered today. So when you have a to the m over n, that is the same as a to the m to the nth radical, okay? Maybe that's a square root, maybe it's a cube root, maybe it's a fourth root, we don't know. But the n, again, represents the index, and the m is the exponent. Okay, so if we were to do a couple examples just for the purposes of your sheet, we might have x to the 2/3, which would be the cube root of x to the 2. Or maybe we just have 4 to the 1/2, which really means 4 to the 1 squared. I'm not squared, oh sorry, square rooted, which is just 2. Or maybe you have, let's do kind of a complicated one. If you have x squared y raised to the 1/3, that's going to be the cube root of x squared y, etc., etc. Okay, I'm not even going to write this middle section for those of y'all that have this middle section written out in words. It just gets wordy and confusing, and I just really don't care about this law as much as I care about the other ones, so not even going to worry about it. Okay, pause if you need to. I'm going to go ahead and move on. Last section of the whole thing is to just, oh, maybe not the last section. Just kidding. But this section, second last section, is the most like the test. This is the most like what I have created for the test, and they're very, very simple, okay? In fact, I would even pause it here and just see how you do, because you might surprise yourself, okay? So pause it now. I'm going to go ahead and work them out. Alrighty, so here's my answers. Just a few things to point out. You might have to simplify an exponent, like on number 5. 3/9 is obviously a third. You might have to flip something to the bottom if you need to. And like on number 9 here, if you wanted to write this as 2 to the 1/4 and to the 1/4, you could. It would not matter to me. Yeah, so hopefully you did okay on that. Okay, last section, again, this is similar to like what the test would be like. I would expect you to actually be able to work most of these out. The ones that have a cube root, I wouldn't really expect. So again, I'm going to pause the video and work out all the answers. So I would suggest you do the same, and then we'll compare. Alrighty, here are my answers. Pause if you want to go ahead and check them all without me talking over you. A few things I'll point out. Notice that like on number 7, for example, we have a square root in our denominator right here, which we're not supposed to have based off the rules we learned about simplifying radicals. However, because that is a perfect square, square root of 49 is just 7, I didn't have to worry about it. I didn't have to rationalize anything, I just worked it out. Square root of 49 is 7, so it kind of took care of itself. Same with number 8. Alrighty, I believe that is the end of the notes. So, again, I know I said this at the beginning, but if that blew your mind, do not stress over it, okay? Especially if you could do that little middle section, this one right here, you should be good to go, okay? This one, this is kind of what the test would be like, is just can you actually translate that a third means a cube root and that a square root is a half? If you can handle that, then you are good for the test, and don't worry about it at all. Okay. Let me know if you have any questions, and I will be happy to answer them.